All right, we are starting chapter 11 today. This is section 11.1, probably something that you've seen at least a little bit before, but I also want to try to show a little bit on the reasons why. So the first question is, what figure do I have here? So obviously it's supposed to be a quadrilateral, and but it's a special, or it's supposed to look like a special quadrilateral. It might not be perfect, but if you had to take a guess at what it probably is, hopefully you would say that it looks like it's probably a parallelogram, that opposite sides here look like they're parallel, opposite sides here are parallel, or look like they're parallel. So again, we usually don't do, hey, it looks like, but for this, we're going to, or I'll tell you that they are supposed to be parallel, right? And the question we might ask ourselves is, what is the area of this figure, right? Or how could we find the area of a parallelogram in general? And maybe you already know, but if you don't, right, what I want to do is to show you how it fits something that I think you do already know, right? So if we were to take this triangle on the side here of the parallelogram, so we cut straight down from the point here, perpendicular to the opposite side. And if we moved it over and filled it in, right, since these two sides were parallel, that means they will fit perfectly there. And you'll notice that this makes it a, this one looks like a square. In general, it'll look like a rectangle, right? So we get this rectangle formed, and hopefully we know how to find the area of a rectangle. It is the base times the height. And that's very, very similar to what we do then, because the area is preserved even if we're moving it, right? So the area of this figure and this figure are exactly the same. Well, this is a height, and this is the length, or here we'll call it the base. So it is just the same formula as finding the area of a rectangle. We do need to know what the height is and the base. So base times height gives us the area of a parallelogram. All right, what if we wanted to find the area of a triangle, right? And we might already know this. Hopefully we do, that it's 1/2 the base times the height. 1/2 the base times the height. But why is that, right? So what if we took a second triangle, and I have it cut to two triangles already, but second triangle that fit exactly into it, right? And we took that triangle and we flipped it out like this, right? So what have we done to the area of our original triangle? Well, we took the exact same triangle and we added it to it. So we've doubled that area, right? And now we formed a rectangle. The rectangle has a base or a length, and it has a width or a height. And if we take the length times the width of the rectangle, right, we should have twice the area of our original triangle. So half the area of the rectangle should give us the triangle. That is 1/2, again, 1/2 the base times the height. So we can figure out that this would be the area. The formula works because of a rectangle, right? So relating it to a different figure that we already know how to find the area. All right, again, today we are looking at 11.1. This is areas of parallelograms and triangles. And our area of a parallelogram like we just mentioned is area equals the base times the height. So if we have a parallelogram, it's the base and the height. And the area of a triangle is 1/2 the base times the height. So if we have some triangle, the height is one of the altitudes, and the base is the side that the altitude is going to. All right, so these are the two important things that we're looking at today. We'll also look at the perimeter of these figures. So let's start with an example of a parallelogram. So we have a parallelogram. Ooh, well, it's supposed to be a parallelogram. Let's see, it would be more maybe there. Does not need to be perfect for what we're doing. We got a side of 16. This is 8, and this is 10. All right, so we're going to ask ourselves two questions. Perimeter and area. And you can do, we're going to go to the nearest 10th for all of these. And you can do whichever one you think is easier first. You can go in order every time if you want to. Doesn't really matter. What you should notice is that the height here of the parallelogram creates a right triangle. All right, so this right triangle has sides of 8 and 16, which means that you should be able to find what the length of this side is. Right? So do that now. Again, you do need that. We go 16 squared minus 8 squared. And I got about 13.9. That's an estimate of it, right? We have, oh, I'm sorry, that's not right at all. How about the square root of 16 squared plus 8 squared, because we're looking for the hypotenuse, and it is about 17.9. Right, this is the hypotenuse of our right triangle, and so we can do that. So perimeter, right, we have a side of 16 and a side of, 18 and 18. So we have 2 times 18 plus 2 times 17.9. Which gives us a perimeter of about 71.8. Going back, this was all in feet. What's our area? Area is easier. It is equals the base times the height. The base is this 18 times the height 16. 18 times 16 gives us 288 feet squared. Let's take a look at another example. (15 feet, 30 feet, and this time it's not going to give us the height. It does, however, tell us that this angle here is 45 degrees. Since this is a parallelogram, this is also 45 degrees. My diagram not well drawn to scale, because this is a right angle, and so this must be 45 degrees. We have a 45, 45, 90. The hypotenuse is 15, and so the other side, which we don't care about that side, but we do care about the height. The height must be 15 over the square root of 2 because of our special right triangles. Okay. Given that we don't actually have to put this anywhere other than into a formula, we can leave it as 15 over root 2. That's fine. You don't have to find what it actually is. Right? Perimeter, this one is easy. Right? It is 2 times 30 plus 2 times 15, which is 90 feet. And the area, the base is 30 times 15 over root 2. 30 times 15 divided by the square root of 2 gives us about 318.2 feet squared. And we're going to look at a triangle or two here. So if we had a triangle, and sometimes in the book it'll make you do a little bit of extra work here, so I'm going to do it like it does there. Usually this part then would be shaded. That's what we're actually finding the perimeter of this triangle and the area of this triangle. And this other triangle off to the side here is just to help us find some information from that. So the first thing that we have to do here is to finish off our sides, right? Well, we have a right triangle with sides of 3, something, and 5. That is our most used special right triangle. So I'm not even going to take the time on it. It's 3, 4, 5, right? Pythagorean triple that we should know. And what's our last side here? It's whatever the square root of 15 squared is plus 4 squared, about 15.5. So we get a perimeter here of 34.5. Now recognize I did put equal. I probably did this once before. It's technically about equal to 34.5 centimeters, right? We rounded here on the 15.5. And our area is much easier, right? We take the base times the height. Given that this was a right triangle, those are just the 2 legs. So we have 1/2 the base times the height. Half of 4 is 2. And so we get 30 centimeters. And I guess we'll try to look at one more real quick. Nine, right, 13. So what you should notice, 2 sides here are congruent, makes us a 45, 45, 90. So this side is 9 root 2. And this is 22. So the third side here is the square root of 22 squared plus 9 squared, about 23.8. And then our perimeter is just these 3 sides, 13 plus 9 root 2 plus 23.8 plus 13 plus 9 root 2. And we get about 49.5. That'll be centimeters. Our area is the height times the base. Our height is 9. Right, it's right here. The base is the length here, only of the triangle, which is 13. The area is 1/2 9 times 13. This would be the altitude from this side, right, from this corner down. It just happens to meet outside of the triangle, right? Altitudes do that sometimes. 1/2 of 13 times 9 is 58.5. And homework will be posted on Canvas.